It's time again for the champion. Today we are looking again at another hidden quantum champion here on the Polaris School of Quantum. And with that, welcome to another episode here of the Hidden Quantum Champion series on the Polaris School of Quantum. And today we are actually not looking at a company, but more at a foundation. And you've probably already seen it on the title of this video. Today's video is going to be about the Quantum Open Source Foundation. And with that, let's go right on to their website. So here we are on the website of the Quantum Open Source Foundation. And you can already see, as it says here, supporting the development and standardization of open source, of open tools for quantum computing. There's a Slack group here for instant chat messaging. There's a GitHub and also a GitLab link related to this open source foundation here. Then also something on the team, find out more about the team behind, and we will do that later on, because now first, as always, we go through the whole website and look at what the value proposition is, or what this whole initiative here is about. So the the QOS Foundation Manifesto, our core beliefs and mission statement, and why you should get excited about us. Then there's also what is open source. Simply uploading your code into the web isn't enough. Learn what open source really means, and I guess that also goes into direction of licensing and managing community and so on. So why you should open source, not sure why you should share your code with the world. Here are 3 good reasons. Then learning quantum, a curated selection of the best free learning resources on quantum computing for all skill levels. I hope very soon also the hidden champions are going to become part of this. So if somebody from the foundation is watching this video, please reach out. I'd be very happy to provide these videos also in the context of what you guys are doing. Then the open quantum software project. So overview of open quantum software projects for newcomers, academics and experts alike. The QC mentorship program, connecting quantum enthusiasts with mentors from academia and industry. The quantum software project evaluation, most recent results of our monthly evaluation of curated open quantum software projects. With the quantum prize, read more about our efforts to reward unsung heroes of the quantum open source software. And then also the quantum software meetups. Meet the people and projects behind quantum software and get involved yourself. And quick mention also on this point, of course, I am a bit biased when it comes to this whole topic, because I'm also a big fan of open source. I think a lot of the technology that we are using nowadays is basically on the fundament of open source, or is based on this fundament of open source. And also I myself have been contributing in education around open source software. You can even find it here on this channel. If you dig a little bit deeper into the old videos, you will find a QCodes software tutorial from me. QCodes is a software environment that is open source, led by the Microsoft Lab to do lab automation in a quantum lab, for example. Okay, so now let's go into the manifesto, because that is linked there. And you see immediately the website design is changing. So here it's really like a pure text thing. It says mission, the Quantum Open Source Foundation, herein after referred to as QOSF, is charged to expand the role of open source software in quantum computing and improve the standardization and quality thereof. The main focus of the QOSF will be on software intended for the use with the current and near-term quantum computing technologies, also often referred to as noisy intermediate scale quantum (NISQ) technologies. The QOSF will also pursue activities and financial support related to the exploration of upcoming open source software for fault-tolerant universal quantum computers on the scale of hundreds of logical qubits. A specific focus lies in the standardization of the low-level hardware interfaces and their compilation in order to allow for cross-compatibility of quantum programming languages. The objectives of the QOSF is to foster collaboration between the quantum hardware and software developer communities, provide financial funding for selected projects and travel awards for selected QOSF members and maintainers of open source quantum projects, incentivize and support the distribution of free and open information regarding advances in quantum software engineering and quantum computing in general, provide a forum for physicists, software developers, quantum hardware providers, and other parties to discuss common problems and obstacles related to open quantum software engineering, organize free and open conferences, workshops, and informational sessions on quantum software engineering, and convey the fundamental concepts of quantum computing and quantum software engineering to the general public. So you see, these are, let's say, the six fundamental guidances. So the idea is to create an ecosystem, an open ecosystem for the near-term quantum computers that are available already today, these NISQ devices, all the way up to what it says here, scale of hundreds of logical qubits, so these fault-tolerant or this error-corrected qubits that you can run very, very long operations on. It's about fostering collaboration. It's about informing people, getting new people in, creating an open environment that everyone can kind of work together in collaboratively. Then on the membership, members in the QOSF, membership in the QOSF is open and free for anyone interested in open source software development for quantum computing. Members and supporters of the QOSF are not obliged to donate to the foundation itself, but are committing to support the values stated in this manifesto. There are no dues of any kind. And then the amendments of the manifesto may be proposed by a petition supported by at least 10% at the time of submission of the QOSF members and must be submitted to the board of directors of the QOSF. The proposed amendment shall be submitted to the QOSF members for vote at the time of our biannual meetings. If approved by vote through an absolute majority of the QOSF members, the amendment is approved. An approved amendment shall be effective immediately unless otherwise specified in the amendment itself. Okay, with that we hop back here. Quickly check out the Learn site. So this is about learning resources on quantum computing. And I mean, if you want to learn more about the technology, I guess, and the let's say hard skills that are underlying, this here is probably a very probably still not complete list, but something that is coming very close to completion of all of the different platforms and tutorials that you can find, including, for example, Rigetti's computing SDK, there's D-Waves SDK, Xanadu SDK, and you see IBM, and many others. There's like courses here, Qiskit, a quantum algorithm zoo. If you don't know about that one, I also recommend you to check it out. It's a list of all the quantum algorithms that have been developed. Then, okay, quantum computing playground, Quirk, Quantum Odyssey, massive open online courses, so MOOCs on quantum technology or quantum computers. There's one from MIT here, but there are also other ones down here in that list. There's the development tools listed here, and there are also some blog articles which you can find, books that are listed here, papers, videos, communities that you can join from the various different programming language like IBM Qiskit or Q#, Women in Quantum Computing and Applications, Penny Lane, and Quantum Odyssey, and so on. And then there's also the code side here. So this is all the open source code projects that you can contribute to, that you can use. So list of open source projects, mirror of the curated list of open source developed quantum software projects hosted in the QOSF's GitHub page. And then here's also some information on how to add your project in case you have one that you want to be listed here. So full stack libraries, you see here, for example, Amazon's Bracket, Avalone, Cirque, Q from NVIDIA, Forest from Rigetti, Ocean from D-Wave, OpenQL, PennyLane, Percival, Project Q, PyCat, Q#, Cadence, Qiskit, Crisp, Silk, Strawberry Fields, Tangelo, Tequila, XACC, XACC, and then Stack. And then there's also quantum simulators, and I'm not going to read through all of them now. You see there's a very, very long list of those in here. Then there's also quantum annealing information, or quantum annealing systems, quantum algorithms. That again points back to the quantum algorithm zoo, right? Quantum compilers, so tools that are compiling gates into, I guess, operations on quantum hardware, available here. The quantum assembly. Then there is post-quantum cryptography, experimental quantum computing. So there you see, for example, Q-Flow Light, QGL, QLab, and so on. Then there's quantum fun as well here. So this is like, I guess, the quantum games and ideas, educational ideas to teach people about quantum. There's quantum tools as well here, and the abandoned projects as well. So projects that I guess have not been worked on anymore. Okay, so you see that's quite a long list, and if you want to learn more about, let's say, the software side of quantum, I encourage you to check that out. There's also something here about the evaluation, so quantum software project evaluation, most recent results of our monthly evaluation for curated open quantum software projects. And there you find some information here, how this selection works. The evaluation is not completely automated yet. There's also some information about that. It says project selection. We only evaluate a subset of the projects presented in our exhaustive list of open quantum software repositories. The following decision tree outlines the process which is used to select free and open software projects for evaluation. The main goal is to identify projects that have already built a community around their project. The acronym PR stands for pull request, which is a form of code contribution on software hosting websites. And here's basically explained how it works. So you see it has to be on some type of upstream, on some type of platform where people can get access to the code. Then there's a license question here. You have to have contribution and the number of commits. So contributors, there should be more than a single contributor, so it shouldn't be just one person working on something, but more like a collaborative. It should be a team. And the number of commits basically means the number of development stages of that code. Like when you start with the project and it's empty and you develop the first functionality, you do the first commit, and then you build on that step by step. And here it says it should be more than 100 total commits, which is still can be quite a small project, right? Like even small projects have thousands of lines of code oftentimes, so 100 commits is not an extremely high number, to say that. Then here it says if it's not this 100 number of commits, then younger than 1 year, then yes. If it's if it's yes, more than 100 commits, then at least more than 20 commits in the past year. So to make sure that it is also still an actively development project, not just something that has been sitting on the shelf for a long time, right? And it says any issues or pull requests from external. If yes, answered more than 5% of issues and PRs, then if yes, project considered in this review. So this is referring to external collaboration. So if somebody finds an issue, they can flag it on these platforms, like for example GitHub or GitLab. And the question is, okay, do people actually take care? There's also pull requests, as in like contribution again. and there's some information here on how this has to be handled. And then repository evaluation is happening here. So it says evaluation results for the static analysis of each project and source code. We report the version control and issue tracking system, as well as the total number, attention rate, and average response time for all open and closed issues and pull requests. We define attention rate as 1i, where 1 Roman 1 is the fraction of ignored issues and pull requests which respect to the total number of issues and pull requests. An ideal project never ignores any of its user or developer questions or contributions and would have an attention rate of 1.0. The average response time measures how long it takes a core contributor or an employee of the company hosting the project to respond to issues or pull requests. Next, we analyze the existence of a test suite and report the resulting code coverage for most projects. Code complexity is only reported for projects written in Python, since other languages do not allow for fast retrieval of this metric. If you know how to do this, please let us know. Okay, and then there's some explanation here, or some table here with all of the different projects. Some further documentation evaluation happening here. So how well is the software ecosystem actually documented? You see there are like different stages here. So there's source code documentation, as in probably like comments and so on. There's a README which should be provided, which is already not the case sufficiently for all of them. Change logs, user docs, and then tutorials. You see that tutorials, in a lot of those you can't find a tutorial on how to use the software. And here it says the image below shows the detailed results for our qualitative documentation analysis in form of a color-coded heat map with sources ranging from 1 bad to 5 good. We evaluate each project based on the quality of their source code documentation, README files, change logs, user documentation, and tutorials. The detailed rubric used for scoring each of these 5 aspects can be found in the supporting information of the review paper, Open Source Software in Quantum Computing. Then there's the community evaluation here. I will quickly also read through that one. Lastly, the following table shows the evaluation results of the community analysis for each project. We analyze if a public development roadmap exists and if the software is published in form of releases. Additionally, we report the GitHub community profile score, the total number of contributors, the type of user and developer-centric discussion channel, and the type of public code review process, specifically if it applies to internal I or external E contributors. And then you can see these things here. And you see the community score, for example, ranging from numbers like 2 all the way up to I think 46 here, so quite a broad range also in here. And also when it comes to the channels, a lot of the stuff is still, let's say, not really actively developed in channels. Some flagship products here or some flagship projects actually have that, but most of them don't have that yet. So in the community profile, you see that they're all scoring somewhere in the center. And only very few of them, I think only this one here gets a 7 out of 7, which is Strawberry Fields project. Okay, now let's quickly also check on the mentorship part of things. So here it says Quantum Computing Mentorship Program, connecting quantum enthusiasts with mentors from academia and industry. You can apply here, apply for mentorship, apply to be a mentor, join the Slack, and donate to the QOSF. General overview: you are invited to participate in our quantum computing mentorship program with the support of a mentor who is an expert in the field and a global community of like-minded people. You'll complete an open source project to contribute to quantum computing software as an individual or in a team of up to 3 members. Then there's some highlights mentioned here from 2020 cohort all the way to 2024. So this also kind of gives you a feeling for how long this already exists. So here we see March 2020 to June 2020 is the first cohort that is being listed here. Then on the timeline, the program is running in cohorts. Here is the timeline for the next cohort, which is number 10, which will start October 2024. I'm recording this in November 2024, so this is already running. If you would like to be informed about updates, please follow us on the different platforms. How does it work? Application, assessment task, mentor and project assignment, project, and then finalization. And here you can see all of the steps, which I'm not going to go through now. Now, finally, let's quickly go back to the starting page. And there is one point which is still open, which I wanted to go through, which is, where is it? Which was about the QOSF itself. So where is it? Open source, connecting enthusiasts. Am I missing something? Here, the team was up there. Our team. So now quickly on the team behind the QOSF. So overview of the main people behind QOSF. We are always looking for new people. So hit us up if you're interested. And of course, call out to everyone here who is, let's say, I need to drink something. Always stay hydrated. So quick call out here to everyone who has a lot of experience, maybe in open source, but maybe also not a lot of experience, but is very curious about and wants to learn about it. Make sure to check them out as well. So here you see the team behind. See there's quite a couple of people. So 1, 2, 3, 4, 5 people that are working on that. And then there's also a lot like core contributors, and then you also have the list of contributors here, as well as a section for the donors. Now, with that, I would already like to close today's video. If you liked it, then please make sure to, first of all, if you are a software person, get in touch with the team. Secondly, if you know somebody else who could have liked it, please share this video with them and share also the channel with them. And with that, as always, make sure to stay hydrated and see you in the next video. Bye bye.